Adding and subtracting polynomial expressions and functions. Term is a constant, a variable, or a product of a constant and one or more variables raised to powers. A monomial is a constant, a variable, or a product of a constant and one or more variables raised to counting number powers. A polynomial or a polynomial expression is a monomial or a sum of monomials. Polynomials. The polynomial 4x to the third minus 8x squared plus 6x minus 9 is a polynomial in one variable. It has four terms: 4x to the third, negative 8x squared, 6x, and negative 9. Polynomials in one variable are usually written so the exponents of the terms decrease from left to right, which is called descending order. Degree of a term. The degree of a term in one variable is the exponent on the variables. For example, the degree of the term 7x to the fourth is 4. The degree of a term in two or more variables is the sum of the exponents on the variables. For example, the term 2x to the third y to the fifth has a degree of 3 plus 5 equals 8. The degree of a polynomial is the largest degree of any non-zero term of the polynomial. For the following examples, we have the degree of the polynomial, the name of the polynomial, then an example of that polynomial. For a degree of 1, it's a linear polynomial or a first-degree polynomial. An example of a linear polynomial: 4x plus 9, negative 6x. For the degree of 2, that's a quadratic polynomial or a second-degree polynomial. Some examples would be 7x squared minus 3x plus 8, x squared plus 5. For a degree of 3, it's called a cubic polynomial or a third-degree polynomial. Some examples would be negative 5x to the third minus 4x squared plus 8x plus 2, and 8x cubed plus 7x. Coefficients. The coefficient of a term is the constant factor of the term. For example, the coefficient of the term negative 7x to the third is negative 7. The leading coefficient of a polynomial is the coefficient of the term with the largest degree. For 3x to the third plus 6x squared minus 4x minus 9, the leading coefficient is 3. Combining like terms. Like terms either are constant terms or are variable terms that contain the same variable or variables raised to the exact same power. For example, the terms 2x to the third y to the fifth and 7x to the third y to the fifth are like terms. The terms 6x to the fifth and 8x squared are unlike terms because the exponents of x are different. To combine like terms, add the coefficients of the terms. In this example, combine like terms. 7x to the third minus 8x squared plus 2x to the third plus 5x squared. Our like terms for this problem are 7x to the third and 2x to the third, negative 8x squared, and 5x squared. 7x to the third plus 2x to the third gives me 9x to the third power. Negative 8x squared plus 5x squared gives me negative 3x squared. So my answer is 9x to the third minus 3x squared. In this example, combine like terms. 4a to the third b minus 7a squared b squared minus 2a squared b squared minus a to the third b. For my like terms, we have to have the same variable and exponents. So I have 4a to the third b minus a to the third b, negative 7a squared b squared, and negative 2a squared b squared. 4a to the third b minus a to the third b is 3a to the third b. Negative 7a squared b squared minus 2a squared b squared, negative 9a squared b squared. So my final answer is 3a to the third b minus 9a squared b squared. Addition and subtraction of polynomials. Adding polynomials. To add polynomials, combine like terms. Subtracting polynomials. To subtract polynomials, first distribute -1, then combine like terms. In this example, add or subtract is indicated. My first polynomial is 3p squared minus 5pq plus 7q squared, plus my second polynomial, negative 8p squared plus 5pq minus 2q squared. We want to combine like terms, so I can add 3p squared and negative 8p squared. That gives me negative 5p squared. Now we want to add negative 5pq and positive 5pq. That's going to give me 0pq, which is just 0. 7q squared and negative 2q squared are also like terms. 7q squared minus 2q squared is a positive 5q squared. So my final answer is negative 5p squared plus 5q squared. I could also have written my answer as 5q squared minus 5p squared. In this example, add or subtract as indicated. My first polynomial is 5x squared minus x plus 5 minus my second polynomial, which is 2x squared minus 7x plus 3. The minus sign in front of my second polynomial will change all the signs in that polynomial. One way to do this is to change your minus to a plus, then change the sign of everything in that parenthesis. My 2x squared becomes negative 2x squared, my minus 7x becomes plus 7x, and my plus 3 becomes negative 3. Now when I add my like terms, 5x squared minus 2x squared, I get 3x squared. Minus x plus 7x gives me plus 6x. 5 plus a negative 3 gives me a positive 2. So my final answer is 3x squared plus 6x plus 2. Polynomial functions. A polynomial function is a function whose equation can be put into the form f of x equals p, where p is a polynomial in terms of the variable x. If p is a quadratic or second degree polynomial, the function is a quadratic function. Definition: quadratic function. A quadratic function is a function whose equation can be put into the form f of x equals ax squared plus bx plus c, where a does not equal 0. This form is called the standard form. For example, the function f of x equals 8x squared minus 2x plus 7 is quadratic because it is in the form f of x equals ax squared plus bx plus c, with a equal to 8, b equal to negative 2, and c equal to 7. In this example, we want to find the following. For f of x equals negative 2x squared plus 5x minus 1. Part A, f of 4. So replacing our x with 4, this equals negative 2 times 4 squared plus 5 times 4 minus 1. 4 squared is 16, and negative 2 times 16 is negative 32, plus 5 times 4 is 20, minus 1. Negative 32 plus 20 is negative 12, minus 1 is negative 13. So f of 4 equals negative 13. For part B, we want to find f of negative 3. So that equals negative 2 times negative 3 squared plus 5 times negative 3 minus 1. Negative 3 squared is 9. 9 times negative 2 is negative 18, plus 5 times negative 3 is negative 15, minus 1. Negative 18 plus negative 15 is negative 33, minus 1 is negative 34. So f of negative 3 equals negative 34. The graph of a quadratic function is called a parabola. The lowest point of a parabola that opens upward is called the minimum point. The highest point of a parabola that opens downward is called the maximum point. The minimum point or the maximum point of a parabola is called the vertex of the parabola. The vertical line that passes through the parabola's vertex is called the axis of symmetry. In this example, we want to use the graph of the parabola to estimate the following. Part A, estimate f of negative 1. First, we find negative 1 on our x-axis. Then we go up to the curve, over to the y-axis. Our corresponding y value is 3. So f of negative 1 equals 3. For part B, estimate f of 2. So we find 2 on our x-axis. It's on the curve, so that means that our y value has to be 0. f of 2 equals 0. Part C, estimate a when f of a equals 0. If f of a equals 0, that means y equals 0. Y is 0 here at the origin and here at 2. These are symmetric points on the parabola. So f of a equals 0 when a equals 0 and when a equals 2. Part D, estimate a when f of a equals negative 1. Finding negative 1 on our y-axis, we go over to the curve, then up to the x-axis, which is 1. When f of a equals negative 1, a equals 1. This time we only have one value for x because 1, negative 1 is the vertex. Sum function and difference function. If f and g are functions and x is in the domain of both functions, then we can form the following functions. Sum function, f plus g, where f plus g of x is equal to f of x plus g of x. Difference function, f minus g, where f minus g of x is equal to f of x minus g of x. In this example, let f of x equal 3x squared minus 7x plus 2 and g of x equal negative 6x squared plus x minus 5. Part A, find an equation of f plus g. F plus g of x equals the polynomial 3x squared minus 7x plus 2 added to the polynomial negative 6x squared plus x minus 5. Adding like terms, we have negative 3x squared minus 6x minus 3. Part B, find f plus g of 2. So we're going to take our answer from part A, and everywhere we see an x, we're going to replace it with 2. Negative 3, parenthesis, 2 squared minus 6, parenthesis 2, minus 3. So that equals 2 squared is 4 times negative 3 is negative 12, minus 6 times 2 is 12, minus 3. Negative 12 minus 12 is negative 24, minus 3 is negative 27. So f plus g of 2 is equal to negative 27. In this example, using the same functions for f of x and g of x, Part A, find an equation of f minus g. F minus g of x will equal my first polynomial, which is 3x squared minus 7x plus 2, minus my second polynomial, which is negative 6x squared plus x minus 5. Because we're subtracting, the minus sign is going to change the sign of everything in my second parenthesis. So changing my minus to a plus changes my negative 6x squared to a positive 6x squared, my positive x to a negative x, and my negative 5 to a positive 5. Adding my like terms, 3x squared plus 6x squared is 9x squared, minus 7x plus a negative x is minus 8x, 2 plus 5 is a positive 7. So f minus g of x is 9x squared minus 8x plus 7. Finding f minus g of 2, I replace my x with 2. So that equals 9 times 2 squared minus 8 times 2 plus 7. That equals 2 squared is 4 times 9 is 36. Minus 8 times 2, which is 16, plus 7. 36 minus 16 is 20, and 20 plus 7 is 27. So f minus g of 2 equals 27. Adding and subtracting polynomial expressions and functions. Degree of a polynomial. The degree of the polynomial is the largest degree of any non-zero term of the polynomial. Addition and subtraction of polynomials. When you add polynomials, you combine their like terms by adding the coefficient. To be a like term, you have to have the same variables and exponents. When you're subtracting polynomials, you need to distribute the minus sign through the second polynomial, then add your like terms. Quadratic functions can be put into the form of f of x equals ax squared plus bx plus c. A parabola is a graph of a quadratic function. The sum function and the difference function. The sum function is f plus g of x, and the difference function is f minus g of x.